We all know that having major surgery can be pretty stressful. But you know what? The recovery can be just as tough, if not tougher. So today, we're going to dig into the science behind a really interesting natural compound called beta-glucan. The big question is, could this stuff be a secret weapon for healing up after an operation?
So what's with this number, 27%? Well, back in the early 90s, some studies found that this was the rate of infectious complications for patients after major surgery. That's more than 1 in 4 people. It's a huge deal, and it really shows you why scientists are always on the lookout for ways to help our immune systems when we're at our most vulnerable. All right, so here's our game plan. First, we're going to talk about that hidden risk that comes with surgery. Then we'll introduce our potential hero, beta-glucan. After that, we'll dive into the pretty wild and conflicting evidence from human trials, look for some clues in animal studies, and finally, try to figure out where things stand today.
Okay, let's start with the problem itself. A major operation puts your body under immense stress, and that can really weaken your immune defenses. What happens then? Well, it creates this dangerous little window of opportunity for bacteria to move in and cause some serious post-op infections. And as research has shown us, this isn't a small risk. It's significant and it's costly. So if your immune system is suppressed, how do you help it get back in the game? For decades, scientists have been looking at these things called biological response modifiers. It's a fancy term for substances that can kind of nudge our immune system into a state of readiness. And one of the most interesting ones they've found is beta-glucan.
So what on earth is it? Well, in the simplest terms, beta-glucan is a type of fiber. It's just a long chain of sugar molecules, or glucose. But here's the catch. Not all beta-glucans are created equal. Their structure, like how long the chain is or how it branches out, changes a lot depending on where it comes from. And that difference is absolutely key to how it works inside our bodies.
And you've probably eaten it without even realizing. You can find beta-glucans in some really familiar places. They're a huge part of the cell walls in baker's yeast and brewer's yeast. They're in mushrooms, and they're also that healthy fiber you hear about in cereals like oats and barley. That's part of the appeal for researchers. This stuff is all around us.
So how does it actually do its thing? Well, I think the best way to think about it is like a training gym for your immune cells. The beta-glucan molecules are recognized by and bind to key cells, like macrophages. Those are kind of the Pac-Man of your immune system that gobble up invaders, and fibroblasts, which are the cells that rebuild tissue. This process acts like a drill sergeant, basically getting these cells primed and ready for action, but without triggering a massive, system-wide inflammation.
Okay, so that's the theory. Sounds pretty great, right? But does it actually hold up in the real world with actual people recovering from surgery? To find that out, we have to look at the clinical trials. And this, my friends, is where the story gets really, really interesting. Because we basically have a tale of 2 completely different outcomes.
Let's start back in 1994. There was a study on 34 high-risk surgical patients who were given a beta-glucan that came from yeast. And the results? Honestly, they were stunning. Just look at this. The group that got the beta-glucan had less than half the number of infections. They spent an average of just 0.4 days on IV antibiotics compared to over 10 days for the placebo group. And their ICU stay? Practically 0. The difference was just incredible.
You can just feel the excitement from the researchers in their conclusion. They wrote that this initial trial showed the compound was safe, and it worked, and that it justifies broader investigation. It really seemed like they had stumbled upon a major breakthrough.
And that bigger investigation? It did happen. But this is where our story takes a very sharp turn. 5 years later, in 1999, a massive trial involving almost 1,250 patients looked at the exact same yeast-derived beta-glucan. And the result? Absolutely no difference in severe infections or death. And it gets worse. The study was actually stopped early because the patients getting beta-glucan were having more adverse reactions. I mean, we went from a home run to a total strikeout. What in the world happened?
Okay, so with the human trials giving us 2 completely opposite stories, researchers had to take a step back and go back to the lab. They needed to understand the basic mechanics better. So they thought, let's forget about infection rates for a second. Can beta-glucan physically help the body rebuild tissue and heal wounds? Animal studies were the perfect way to look at this up close.
And a 2013 study on rats that had intestinal surgery gives us a really interesting clue. Scientists measured something called anastomotic bursting pressure, which is basically a fancy way of saying they tested how strong the reconnected tissue was. The results were pretty clear. The wounds in the rats that got beta-glucan were significantly stronger. They could handle way more pressure before they gave out.
So a stronger wound is great, but what does that actually mean inside the body?
Well, it points directly to better tissue repair. It looks like beta-glucan was stimulating those fibroblast cells we mentioned earlier, which then ramped up collagen production. And collagen is like the rebar and concrete for your body. It's the protein that gives our tissues strength and structure.
Okay, let's take a breath and try to put all these puzzle pieces together. We have one small but amazingly positive human trial. Then we have one huge, really disappointing, and frankly, concerning human trial. And then we have these animal studies showing a clear physical mechanism for better wound healing. So, what's the final verdict?
This table really sums up where we are. On one hand, the evidence suggests that, yeah, beta-glucans can prime our immune cells and they can improve how wounds heal, at least in animal models. But on the other hand, we still have these huge, unanswered questions from that failed human trial. Why did it fail? Was it the specific type of beta-glucan? Was the dose wrong? The delivery method? We just don't know for sure.
And that brings us to our final thought. The science here is complex, and the clinical story is, well, it's messy. But the basic idea that a natural compound found in yeast, in mushrooms, and maybe even in your breakfast oatmeal could help our bodies heal, that idea is still incredibly powerful. So this secret weapon isn't quite ready for the operating room yet, but the search for how to use it is definitely far from over.